Some of us have more of it, some of us have less of it, but we can all agree that our not so distant ancestors probably had a lot more of it than any of us do. Hair has played a crucial role in the history of hominin evolution and in the history of endothermic mammalian life in general. Being a feature with multiple applications, it has proven to be a great evolutionary acquirement. However, for modern humans, it seems hair has diminished in its importance and no longer serves nearly as practical a purpose as it once did. Being relegated to a single dense cluster sprouting from a patch of skin atop the cranium where it still claws onto its last vestiges of waning relevance. The utility of hominin hair has experienced quite the fall from grace indeed, with many of its once necessary functions having been transmuted to largely sociological ones. The interactions many of us have with our hair are limited to simply styling and pruning it to appear most aesthetically pleasing to ourselves and those around us, if not the outright removal of unwanted hairs from various parts of the body through plucking and shaving. Some, in fact, go as far as to intentionally damage the fragile hair-producing follicles all over their body in an attempt to semi-permanently ensure the eradication of body hair. I couldn't think of a more clear indication than this that hair has lost virtually all of its utilitarian relevance to modern humanity. If you were to conduct a review of recent historical evolution and fashion trends, you'd be forgiven for thinking that the primary accomplishment of modern human evolution, more than almost anything else, has been the progressive shedding away of the sparse relics of its once plentiful ancestral coat. It is, along with the vanishing wisdom tooth, a silent victim of hominoid evolution. But that's enough wallowing about the naked sorrows of the newly hairless simian bipeds. What can be pieced together about the widespread adoption and subsequent advantages of having evolved hair? Well, before delving into evolutionary history, we should first at least comprehend exactly what constitutes hair and why it may provide some utility. A single strand of hair consists of long chains of protein monomers, each of which consists of amino acid conglomerations covalently bound together in succession. These proteinous polymers are extruded out from organs known as hair follicles, which are embedded in the dermal layer of the mammalian skin. The dermis itself being a layer of skin which is intermediate between the epidermis and subcutaneous layers. These follicles consist of many different cell types functioning concomitantly with each other. Also, the growth of the hair shaft itself is controlled by the host follicle via the interaction between varying levels of many different biomarkers. These hairs don't just include the starkly apparent terminal ones on the top of the head, they also include the countless vellus hairs present all over the body. Hair has such a pervasive influence on human development, in fact, that they can even be found on newborn babies in the form of lanugo hairs. As mentioned earlier, the process of hair growth itself is a regulated and multi-stage process, with the various segregated stages of hair growth involving the further elongation of hair itself, the resultant shrinkage experienced by the hair follicle, a nice little break in between, and finally the shedding of hair. These stages do not occur in equal proportion, however, with the vast majority of hairs at any given time on a healthy human body being in the active growth phase, and a minority of follicles existing in the rest phase, with an even smaller number of follicles actively shedding their hair shafts at any given time. Surprisingly, the growth of hair is quite a resource-intensive and laborious process for the body. As a result, there is much biological infrastructure involved in keeping the hair growth racket afloat. Hair follicles are often accompanied by sebaceous glands and what are known as erector pili muscles. These are simply smooth muscle bands used to anchor the follicle. And from this holy trinity, the pilosebaceous unit, as it is known, forms. These units cover most every surface on the skin aside from the palms and the soles. To delve even deeper, the hair follicle itself is made up of numerous requisite components responsible for blood supply, the creation of new cells, connectivity, etc. These additional facilities allow the hair follicle greater applicability than it would enjoy were it to exist on its own, such as the ability to detect the position and movement of the hair shaft. Now, all of the various components mentioned above dependently function to form millions of coherent and independent hair growth organs. An important quirk of hair growth to note is that it occurs at different rates at different parts of the body. An obvious point to make, but an important one nonetheless. The long flowing tresses of hair that may waft around your head are different to the short inert hairs that grow above your orbital rim. This is largely due to the differences in hair growth cycle lengths and the relative duration of each phase occurring within said cycle. For example, the cycle for eyebrows takes roughly 4 months to complete, while the estimated completion of the growth cycle for hair on the scalp is a number of years, although individual variation is quite large in this aspect. This explains why eyebrow hairs tend to remain quite short and don't require regular cutting like head hair does. This brings me onto an important point. Why can humans uniquely grow hair to such extreme lengths on their scalps? We don't really observe this trait occurring in any other species, so why do humans exhibit it? Well, this seems to be due to humans having incredibly long growth phases for the terminal hairs on the scalp. A number of other species also show prolonged hair growth, but their cycles are typically nowhere near as long as the growth cycles humans can experience. Also, these prolonged growth cycles in other species typically have some clear purpose accompanying them, such as horses being able to grow lengthy tails in order to keep biting insects at bay. The existence of a dense patch of hair growing out of the scalp can be explained a number of ways. They may help protect the brain from solar radiation, they may prevent overheating in high temperatures and possibly prevent excessive heat loss in cold temperatures, etc. Considerably less consensus exists as to why head hair can grow to be so much longer than hair on other areas. The leading ideas behind this phenomenon seem to be that individuals who are capable of growing long, lustrous locks of hair are likely to also possess other genetic advantages. In essence, the idea is that in order to be able to shelter oneself from danger for long enough, procure enough calories to permit abundant hair growth, and be able to escape from predation effectively enough such that a major hindrance like long hair isn't enough to ensure capture, then the long-haired individual in question must have genetics desirable enough to have permitted and sustained this expensive handicap. Essentially meaning that the evolution of long hair on the head served as a proxy trait which indicated the fitness of an individual who could support it. The other less interesting but also likely equally true theory posits that the trait evolved simply due to sensual selection. Early human individuals, likely males, found other early human individuals, likely females, who could produce long lengths of head hair more attractive than those who couldn't. This provided a selective advantage and over time favored the ability to grow longer head hair. Although it is admittedly likely that long hair to some extent was found attractive in both early human males and females, given that today all humans exhibit long terminal hair growth cycles. If we were to more generally discuss the advantages that hair provides, they would be as follows. Hair can be used to provide very effective insulation from extreme temperatures, allowing hair-toting mammals to survive in virtually all temperatures on Earth, from the unrelenting freezing cold of the poles to the burnishing heat of the deserts and the equator. In the case of frigid cold, they can spontaneously stiffen themselves using those piloerector muscles we talked about earlier. This creates an insulative layer of warmer air in the area immediately surrounding the organism, thus decreasing the temperature gradient between the animal and the environment and drastically reducing heat lost via radiation and convection. Hair can also be adapted to provide highly effective camouflage depending upon the characteristics of the organism's habitat. This provides mammals with a particularly effective form of camouflage due to the granular effect of camouflage achieved through hair coloration. This means each individual hair, being essentially its own unit, can produce a color entirely distinct from that of its neighboring follicle, allowing for the generation of intricate coat patterns such as stripes, spots, rosettes, etc. This individuality and independence of each unit, which possesses its own glands and nerves, also allows the hair to act as a sensory tool, feeding information back to the nervous system. Although admittedly other classes of animals also have their own highly effective methods of camouflage that mammals simply, unfortunately, do not have access to. Hair can notably also be used as a defensive tool. This is perhaps exhibited best in the house cat. If you've ever seen a frightened or agitated cat, you know they can pilo erect to quite astonishing degrees. This allows them to give off the impression that they are physically larger and more imposing than they actually are. Hair can likewise be defensively used as a warning signal. Brightly and boldly colored fur can be indicative of a dangerous organism. Now, this has by no means been an exhaustive list of the uses of hair, but I hope it imparted to you the sheer breadth of utility this simple trait can have. Well, on to the question of its origin. Why did hair evolve in mammals? According to what the fossil record reveals, hair seems to have originated amongst the ancestors of the most seminal mammals, known as the synapsids, roughly 300 million years ago. Although, again, like most estimations of ancient evolutionary chronology, these are only estimations surmised from the fossil record in its current state. Entire clades of earlier organisms which may have exhibited hair growth could easily have been missed simply due to an incomplete and inaccurate record, especially when it comes to the preservation of transient soft tissues such as hair. It is theorized that one of the main evolutionary benefits afforded to early adopters of true hair is the sensory benefit it imparted. Early small proto-mammals rummaging around in small enclosed spaces, often in the dark, likely found hair in the form of whiskers to be useful in allowing them to sense the environment around them and better inform them of approaching threats, shifting burrow walls, or the direction of airflow. Mammalian skin is also notably quite fragile and often exposed to intensely damaging abiotic factors such as UV radiation, temperature, etc. Not to mention the threats posed by biotic factors such as insects and other arthropods or injuries from rival competitors and predators. Evolving hair in the form of fur could have helped these early would-be mammals shield themselves from predators or at least negate some of the more gruesome injuries sustained had they not had a thick down jacket of fur. The aforementioned benefits of thermoregulation and camouflage were likely also not lost on synapsids in the cold, unforgiving, and certainly dangerous world they found themselves in. The ability to remain hidden for long periods of time in unfavorable environmental conditions most definitely would have proven useful to them. A rather uncanny ability of hair is the shielding it can provide an organism from rain and moisture, providing creatures exposed to intense torrential rain or monsoons with much needed relief. The list of advantages provided so far likely all contributed in part to the multifactorial rise in the adoption of hair amongst proto-mammals. You can't necessarily point to any one advantage or trait that was the reason amongst reasons as to why hair evolved and persisted. Especially when coupled with the shakiness of the fossil record, stating absolutes like this is often ill-advised. The likely reality is that no particular contributing factor was responsible for hair evolution. Rather, it was the meta-factor of adaptability. The large and widespread applicability of hair may have contributed to mammals enjoying the extensive range of inhabitation that they do today. Found natively on mostly every continent, and where they weren't natively found, they immediately and effectively adapted and thrived there. The high degree of flexibility and ecological adaptation that hair allows is the most compelling theory as to why it evolved and spread. Although it may not be so useful to you these days, it certainly helped your distant ancestors preserve and project their lasting influence.